Welcome to Old Iron Machine Works. In this video I'm going to be rebuilding a Waukesha 7044 water pump, which I do a bunch of them. Maybe not super exciting, but I do want to try to put out some more content. So hopefully you'll get something out of it. Okay, as you can see, they definitely got their life out of this water pump. This pump has been it's been rebuilt several times. These engines run 24/7, and probably the worst impeller that I've ever seen on one. But once they start getting a lot of wear, pretty soon, the cavitation really wipes them out pretty quick. But this is still a salvageable water pump. Okay, I know for several people that may be viewing, they may not have any idea what a 7044 Waukesha water pump is off of. Well, these are some big aerial compressors that actually have the Waukesha 7044 engines running them. And clear to the right on the front of the engine is where the water pump would be mounted. And then beyond that, outside the building would be the, big, huge radiators for cooling. Here, this was a week we had to go swap a head out right there. Natural gas engines, you don't have much lubrication in the fuel. So it is pretty hard on valves. And, once a valve starts to burn a little bit, compression drops down and you got to swap the head out. This is actually a little pumping station where a lot of gas wells feed into this, to these units, and then they just basically send the natural gas down the pipeline. Rio Vista, way back, was always known for a lot of natural gas wells, and even though it's not quite like it used to be, still a lot of natural gas around the area. Well, we'll get back to rebuilding the water pump now. I just thought I'd show a little clip of the engine, so if somebody's going to take the time to watch a rebuild of a water pump, at least they have an idea of what it comes off of. I've had these snap ring pliers for many years, over 20, and they're kind of neat. They're internal or external, and you just kind of push a couple buttons on them, and that's what switches them. And then they also have a ratchet, to where they hold the snap ring when you crimp it. Most of the time when I rebuild these, those two threaded holes are basically for a puller. And I can generally, there'll still be enough material left. But as you can see here, there wasn't much there. So I just had to put some washers and nuts on the inside in order to pull what was left of the impeller off. And here I'm just pulling the mechanical seal off the shaft. Okay, what I did there is heated up the nose cone part of the water pump in order to soften up the Loctite. I'll talk more about it in the video, but these shafts and new bearings are Loctited into the housings themselves, and it actually saves the housings and keeps me from having to throw them away. Although on this particular one, it has been repaired sometime in the past. Okay, this is what they call a double row bearing water pump, and as you can see, the remnants of what's left of it. Yeah, pretty bad shape. Double row bearing basically just means that each bearing has 2 rows of balls. They did make a single roll. The old water pumps were just a single row bearing, which meant each bearing just had 1 row of balls in it. Now, when I said this thing's been repaired before, I'm meaning it's been bored and sleeved before. And again, I'll talk a little more about it. Okay, that little spacer that you see on the impeller with the nylon ties, you would only use that spacer if you were using this impeller on a single row water pump, which we quit rebuilding those 20 years ago. And this is my version of Vapor Rust. This in the glass bead cabinet. Okay, let's try to get this a focus. What we have is this pump's already been machined and sleeved. There's the seam right here, so it's got 2 sleeves. This section, and then you can see this lip right here. It's got another sleeve here. From there to there. And my phone, let's try to get it to focus a little better. There we go. Okay, and the lower sleeve is from here to here. There's the lip right here. This bearing right here is what we got to get out without loosening up and having this sleeve pull out. So we're going to make a slug that welds inside of here, shrinks it up, knocks it out without disturbing this sleeve. This is just my version of a little splatter shield when I weld up the slug. I don't want to have to deal with the dingleberries or, you know, where the bearings go. Okay, if somebody is not familiar with welding to get a bearing out, anytime you weld anything, when the weld cools, it shrinks. So by putting a solid stock in there and then welding a bead around it, when it cools, it just kind of pulls the bearing in and helps knock it out. As you can see here, though, this is the first time I actually had a bearing break in half. So now I got to go back in with another thinner slug, weld it up, and finish knocking the rest of it out. Here when I welded it, I had a little bit stick to the seal, and it kind of pulled the seal out with it, which was just fine. Alright, I got both halves of the bearing out now. And then that's what the brand new bearing looks like. The reason why this pump was bored and sleeved, and the reason why I Loctite all the water pumps I do, is the original ones did not have an interference fit. It was a slip fit, and when the bearings would go out, it would lock the bearing to the shaft, and then the shaft would spin, and the outside of the bearing would just wipe out the housing. That's why I Loctite them. As you already seen with this particular video, the shaft can totally wipe out and disintegrate the balls of the bearing, but the outside's still able to just heat it up and knock it out without having to go and remachine. And here I'm just putting in the ceramic portion of the mechanical seal. The ceramic has a little rubber sleeve around it that goes between the ceramic and the housing itself, and then I just put a little sealer on, you know, just to kind of help seal to the rubber sleeve. Alright, on the mechanical seal, you want to make sure that everything is super clean on them. And if you get anything at all, you know, from any kind of a sealer or oil or anything. You want to make sure you wipe it off and get it all off. And I'm just using some brake clean here on it. Here I'm popping off one of the shields. That's just a shielded bearing. And I always pop the inside off because once I get both bearings on the shaft, I pack it with grease. And I want the grease to be able to heat up and, flow from both sides of the bearing. And sometimes the shield kind of prevents the grease from getting in there. Okay, here you can see the slug I'm using to press the bearing on. You just want to make sure it's a nice flat surface, and when you're pressing the shaft in the bearing, you want to be able to support the ID part of the bearing when you're pressing, just so it's not putting stress on the balls. Anytime I'm pressing against something that has threads on it, I'll always put some piece of aluminum. This is just a piece of nylon, just so I don't, press and booger up one of the threads. Okay, now I'm going to put the lip seal right there. And what the lip seal does is just keep the grease where the grease is supposed to be. And there's always a weep hole between the water section of the pump and the grease side or oil side of the pump. But here I'm just installing this seal. Okay, I already got the bearings all packed, and then I filled the area between the two bearings with grease. And if this was an original Waukesha pump, they would have just thrown it in the housing. But like I mentioned before, I don't want the outside of the bearing to ever spin in the housing. So it will get Loctited in. And of course, with Loctite, you want it as clean as possible. Okay, right there, that little lip there, shoulder, is the only thing that limits the impeller, the depth of the impeller. Unfortunately, that shaft's got to slide down through there and go through the lip of the seal. And you can't really get to it from the other side. So many years ago, I made a little sleeve, which is right there. And what I'll do is I'll shove that down into the seal, just so I know that it's in the seal and the spring and everything is still on the seal. And then I'll slide the shaft in place. Now, on an original housing, this shaft would just drop right in. But since this water pump has been bored and sleeved, whoever sleeved it snugged it up a little bit. So I did tap it in. Um, but unfortunately, on these water pumps, there are no adjustments. Everything goes in up against the shoulder. Snap rings go in. There's really no adjustment on the pulley or the impeller. Unfortunately, when they machine this, they got the depths wrong, and you'll see later in the video I have to machine the impeller to correct for that. Okay, these snap rings have a little taper on them, and they're designed to go into the groove, and then the deeper they go into the groove, they kind of wedge tight against the between the groove and the bearing, and pretty much eliminates any play. And you'll see once I get it in there, then I'll just tap one end of the snap ring just to kind of bottom it as deep as it'll go into the groove. Okay, here they have an O-ring that slides on. It'll slide onto the shaft, and then it'll seal right to the pulley, and that just keeps any of the grease from ever wanting to, leak out and start slobbering around the pulley area. And here we have another lip seal that pretty much keeps the grease in its place and not slobbering out. The original pumps just had a slip fit there on the pulley, and just the friction from the nut being tightened up kept it from spinning. And a lot of the newer style kits, they'll have a Woodruff keys in the shafts. But to me, it's really not worth going and putting a keyway in a pulley. The original setup worked pretty good, and by the time you put a little Loctite on it and tighten everything up, I've never had a problem with one yet. Okay, we got that side of the pump all done. Now it's time to address the impeller side. Okay, I mentioned earlier when they bored and sleeved the water pump housing, they got the dimensions off. And what that did is it let the water pump impeller set out too far. So here I'm just checking exactly how far out it is to decide how much I need to machine off of the impeller itself. Okay, here I'm looking for an end result of, roughly around 10 thousandths, give or take, um, set in, from the main surface of the housing. Okay, both those surfaces I'm going to machine down 50 thousandths. And as you can see here, not a lot of clearance. Alright, I got the impeller on, just the nut snugged up, and I just got the straight edge with the gasket, just kind of checking clearance. And here we're ready to put the mechanical seal on. Once again, I'm using the same tool I showed earlier. And here I'm just kind of carefully working around, pushing it on just a little bit at a time. The rubber seals right to the shaft, and it's a pretty snug fit. Okay, normally the shoulder on the shaft would be pretty flush with the rubber on the seal, but remember that shaft was 50 thousandths out farther than it should be. But not a big deal. That's why I machined the impeller, and The spring just pushes the seal up against the ceramic. Okay, now this shaft now does have a Woodruff key in it, and it does key to the impeller, so there's no need for any kind of Loctite there. The only thing that gets Loctited now is just that nut. You've probably noticed the housings, how corroded they get. If we machine those surfaces every time, we would have nothing left. And we actually have no problems with gasket leaking areas. It's always the mechanical seals, that go out. So even though they look pretty rough, they still seal up pretty good with the gaskets. And this brings us to the end. Here we have a water pump ready to go back on. I appreciate anybody that takes the time to watch my videos. This is just some of my shop related stuff. I have a lot of it. So please leave in a comment if you like this kind of stuff. I have lots more of it. Once again, I appreciate you taking the time to watch my videos.